So we'll begin our study of functions by looking at transformation of functions. And this is going to be section 2.6 in the book. And this section is going to be a very geometric and useful section. There's going to be a bit of work setting up the relationship between the geometry and the algebra, but the payoff is very nice. Let's summarize the different transformations that we're going to be talking about today and the main ideas of the section. So this section is going to be broken down into 5 different pieces. And in the first 4 sections, we're going to be talking about transformation of functions. Let me go ahead and write these down. The first section will be talking about vertical and horizontal shifting. In part B, we'll be talking about vertical stretching and shrinking. In part C, we'll be talking about reflections along the x and y axis. And then in the last section that deals with transformation of functions, we'll talk about horizontal stretching and shrinking. Then, in the final section, we'll introduce this idea of even and odd functions. These type of functions are going to be invariant under certain kinds of transformations. Before we look at any of these topics, let's look at some motivation of where this appears in calculus. So we're going to bring up the idea of a derivative real fast, but we're not really going to explain what a derivative actually does. Instead, we're going to look at a picture and see what the derivative tells us. Suppose we have 2 graphs here. We'll call this first graph f, and we'll have a red graph, and let's just go ahead and call this graph g. What we'll see in this section is that we'll be able to rewrite our function g as f of x plus some constant c here. And so we're looking at a graph that's just been shifted up by c units. Now let's go ahead and bring in the idea of a derivative. A derivative is denoted by d dx, and a derivative operates somehow on functions. So the reason why we're interested in derivatives is because the derivatives tell us about the local behavior. And so looking at these 2 functions, f and g, if we applied the derivative to these 2 functions, we should think that they're going to give us the same local behavior everywhere because these functions look exactly the same everywhere except one has been shifted up. And that's exactly what the derivatives of these 2 functions tell us. That the derivative of f of x is going to be equal to the derivative of f of x plus c.